Our second part of lesson 2 is going to have us generate our equation for our quadratic function using Gaussian elimination and using the grapher calculator. So it's going to be a grapher heavy class, so you'll need to have your grapher in class. But it should be hopefully just a quick set of directions, and then we'll take care of your questions as you have them. Make notes in the margin of your notes if you do have questions for me, just to ask, and then obviously we'll practice this when we are together. But basically what we want to be able to do is, the 2 times ago when we had the vertex and another x comma y, we could figure out what our a value was using the distance from the vertex and the vertical transition to figure out our a value. If we had the vertex, we had h and k. Here we just have 3 random points that are on the parabola, and our goal is how do we write the equation, the y equals ax squared plus bx plus c equation. And so what we're going to do is we're going to recognize that for each one of these we have an x and a y. We have an x that goes in and a y that comes out, an x that comes in and a y that comes out. And this x is paired specifically with this y, and this x is paired specifically with that y. And so when we put in this value of 5, we get out the value of 16 on the other side. And so what we're going to do is write these x comma y's as a system of equations, and then we're going to use Gaussian elimination to handle that. So in order to do this, I'm actually going to write this as ax squared plus bx plus c equals y. We're going to put this in kind of the other direction, and we're going to take each of these x comma y's and write an equation not knowing what a, b, or c are. Instead, this is going to be our variable. So we're going to have a times this x squared plus b times this x plus c is going to give us this y. And when I take a times this x squared plus b times this x plus c, I get this y. And finally, when I take a times this x squared plus b times this x plus c, I get that y. And so this should start to look like the systems in 3 variables that we worked with back in Unit 1. We are going to multiply these just to make sure that things go well here. -1 squared is +1, so I get 1a. -1 times b, I get the opposite of b, and then c is always going to be 1c. It's going to work itself out. 2 squared is 4, so I have 4 times a. 2 times b is a positive 2b, and then c will always be by itself. So 22 right here. 5 squared is 25, so I've got 25 times a, and then I have 5 times b, and then c by itself again, and that's going to give me 16. So now we have this system of equations that looks like a system of linear equations in 3 variables, all right, as opposed to this quadratic equation. But what we're going to do with this information is we're going to make our matrix. 1, -1, 1, and -8. 4, 2, 1, 22, 25, 5, 1, and 16. This is going to be our augmented matrix for this system that we created based on our desire to find a, b, and c that would make a quadratic relationship between these x's and y's. All right? So now we're going to use our calculator. We're going to make sure that we type all of those elements into matrix A so that we have 1, -1, 1, -8, 4, 2, 1, 22, 25, 1, I'm sorry, 25, 5, 1, and 16. All right, so that matches up with what we want to do. And then we're going to use our reduced row echelon form of matrix A, and that will give us our solution. 1, 0, 0, -2, 0, 1, 0, 12, 0, 0, 1, 6. And so we're going to write down the reduced row echelon form. 1, 0, 0, -2, 0, 1, 0, 12, 0, 0, 1, and 6. So this augmented matrix in reduced row echelon form tells us our A value, our B value, and our C value for the quadratic function that has those 3 points. So we're going to have negative 2x squared plus 12x plus 6 as our equation. All right? Now I would like for you to try to do that same thing, all right? Plugging in the x value that goes to the y value, make a quadratic, make a system of these A, B, and C values, and then type it into your matrix and use the reduced row echelon form. So I do want to see all of these steps along the way so that you can get your equation by doing all of those things. This is the example that I would like for you to try. We have these x comma y's. This is still example 1, it's just example 1b. And this is the one that you are going to try to do. So give this your best shot. Negative 218, 1, 6, and 3, 8. Pause the video, work on that, and then turn it back on when you're ready. And we'll talk about that answer in class. All right. Another concept, though, is this idea of regression, where we can see the data and we can generate a parabola of best fit, all right, if you will. So try to remember when we had line of best fit. Here I can say, all right, these are the grades for the students in blue 2 and blue 3, and these are their scores on the y-axis. On the x-axis, it's how many missing assignments they have, all right? So if you're missing more, you can kind of tell that if you're missing more assignments, your grade is probably lower than those who are not missing assignments, all right? Just because you miss an assignment doesn't mean that your grade is automatically a terrible grade, but we can kind of see that there is a connection between number of missed assignments and decrease in your grade, right? And so we use line of best fit for analyzing data that follows a linear model, but sometimes our data will follow a parabolic model. And so we will use something called quadratic regression, and we'll be able to do this using our grapher calculator. The directions for this are going to be a little fuzzy, really, until we do them in person together. You can also do a search for other YouTube videos that talk about quadratic regression using, and then type in your calculator name, the TI-84 or the TI-83 or the Casio, whatever. But this kind of will let us generate a model equation. It's not going to give us exact values, but it'll give us approximations so that we can maybe make predictions about where things should be if we follow that same quadratic model. All right, so here's a situation where we have someone who is, going to throw the discus, and we're going to record the distance in meters horizontally versus how high the disc actually goes along that trajectory. And so what we're going to do is we're going to use a list function in the calculator, and this is a little bit hard to manage, but where we're going to go with that is we're going to use this stat button right here. And in that stat menu, you should be able to edit your lists. So when you press stat, the first thing on the list is edit. And we're going to enter in all of those values that they give us in that table. All right, so I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. But then in list 2, the L2 column, we're going to line those up so that we have 1.75, 2.71, 3.52, 4.28, 5.45, 6.12, 6.79, 7.34, 7.99, oops, too many nines. There we go. And 8.55. And so what we can do with these values, once we have them as sort of an x comma y, is we can use the quadratic regression model, which is still in the stats menu. All right, actually let's go back to the home screen. Stats menu, and we want to calculate a quadratic regression, number 5 there. Now again, if you do not have this calculator, you might have to do a Google search for how to do it with your calculator, all right? Again, this is the calculator that I advise to use. It makes it a whole lot easier if you're using the same calculator here, but quadratic regression, the X list is going to be L1, the Y list is going to be L2, and we're going to leave these as they are, and we're just going to click calculate. And then what this will do is it will generate an A, B, and C value so that we can trace a parabolic model, all right, a graph of this data, so we can see what that would look like in the graph form. So the next time that we're together, I'll show you that stat plot option so I can turn the L1, L2s on. And when we look at the graph, let me zoom. I should be able to see everything in here. I can see those x comma y's plotted. Whoops, there's a y equals in here, sorry. I can see those dots plotted. Now I can also take that A, B, and C value that I just got and I can graph a parabola and it should fit that data. So if I go back to that home screen, second entry, and I take this as an A, B, and C value, I should be able to type that into my grapher. So let's see what that looks like. All right, so I wrote all those values up at the top of the screen, and now what I'm going to do is I'm going to type them into my grapher so that I can graph that parabola as well. Negative 0.027083333, and that's x squared, plus 1.058280303x's, plus 0.06721666667. All right, now when I graph that parabola, it should fit that data. Booyah. All right, and it goes right through mostly those points, right? It gets kind of close, maybe it's off a little bit, maybe it smacks them right in the middle, but there we've got that parabolic curve, and it's going to fit the data that we have been given here. All right, so the point on that, obviously that's going to be a little more curious just depending on how you approach your calculator usage, but it is a great way to model a quadratic relationship between x values and y values. And that's really all that we're going to be doing in class next time, is that we're going to be fiddling with the calculator to take care of some quadratic regression. We'll also be using the calculator to do some Gaussian elimination and writing systems to help us determine our A, B, and C values.